Well, it means a lot of different things to different people. And so for me, I consider anything that has to do with the topics we teach in electrical and computer engineering that have applications for biology or medicine. Interestingly, there really is only one course at Ohio State that combines concepts of electrical and computer engineering and biomedical engineering or medical principles officially. And that's the class that I teach on medical imaging. And in that class we talk about the physics and applied mathematics for how we collect images to do in vivo imaging, things that you go to the hospital or to a doctor's office to get scanned. You get an MRI scan or get an X-ray CT scan or get ultrasound scans or you get a PET scan or some combinations of those. We teach in that class how that stuff is done. But an interesting thing is that almost every course we teach in electrical and computer engineering department has some application for medicine.
The one thing that the Wright Center has is having such a large portfolio. It allows folks to be able to pick and choose from the areas of interest and to be able to match those areas of interest with the available expertise, the available technologies, and even grow that further. We love working with students here at the Wright Center because everyone talks about, and I've made this comment several times about, understanding the box. And the nice thing working with students, they don't understand what the box is, so they work outside those parameters, and they themselves help give birth to further innovations that benefit the individual that unfortunately has been hospitalized, to the pet that's coming in the door to be imaged, to the company that's outside of Columbus, Ohio that may be producing equipment so that they can take further innovations out into the commercial workplace.
If you're interested in a medical application, come over here. Talk to Dr. Kleinman, talk to somebody in radiology and just say, hey, can I get a tour? It all starts with there. Get a feel for what is it like, because when you start, when you're interested in something, most of the time you really don't know what that is exactly. You have to get exposed to it for a little bit before you really know whether that is really what you want to do. So just talk to people, get a feeling for it. If you want to get exposed to actual research and you're not taking classes during the summer, just come hang out with us for a summer, and we'd be more than happy to tag you along and get a real feel for what we do every day.
In pulmonary and critical care, the intensive care units, every piece of patient monitoring equipment involves engineering technology, and that's where a lot of the new advances are coming about these days. For example, this is an electromagnetic navigational bronchoscopic procedure. This is what we see here through the end of our bronchoscope with a special piece of equipment at the end of it. And as you go down the airways, you can see the line telling you which way to go, ultimately leading you towards your target, which is this green dot here. And one of the other advantages of an engineering background in medicine is that as technology continues to evolve, there will continue to be opportunities for people who have a background in engineering in all aspects of medicine and medical care.
The natural research areas from physical sciences and engineering with medicine evolved more through biology applications or through chemistry applications, and in some cases through physics applications. And so, for example, in medical imaging, you see the people that started computed tomography, used to be called CAT scan, were essentially physicists and mathematicians that built that. And it was engineering people that started to mature it and make it more useful for clinical practice. And in NMR and MRI, the early days, it were chemists and physicists who were the primary people that were doing the research and development for MRI machines. And once the electrical engineering people started getting involved, we started making it much more flexible. We could start exploring much more of the things that the actual devices could do, going beyond first concepts and making it a well-engineered tool. And so one of the things that I can see is, still electrical and computer engineering are things that haven't been well explored for medical applications yet. It's an untapped area, and I think it's an area that both areas can grow significantly by looking at the intersection of skills in medicine and skills in electrical and computer engineering.